welcome. I'm Mrittika Prakash and I'm an intern at cybersecurity. Today we're going to take a deep dive into IDOR, Insecure Direct Object Reference. This is one of the most commonly exploited vulnerabilities in modern web applications, and understanding it is essential for anyone working in application security or web development. Throughout the session, we'll cover the theory behind IDOR, looking at real-world examples, a walk through a live practical demonstration, and talk about how to detect and prevent it. Everything you'll see in this practical section was conducted strictly in a designated lab environment. Here's what we'll be covering today. We'll start with what IDOR actually is, and then move on to how it works mechanically, and after that, we'll look at some notable real-world breaches caused by IDOR. We'll discuss the impact and risk it poses to different organizations, and then we'll go through a hands-on practical demo in a lab setup. And finally, we'll close with how to detect and prevent this vulnerability. What is IDOR? So basically, the definition is the full form is Insecure Direct Object Reference, and it is a type of access control vulnerability. It occurs when an application exposes a reference to an internal implementation object, something like a database record ID, a file name, or a URL parameter, without performing a proper authorization checks. To put it simply, the application is trusting the user to only look at their own data rather than enforcing that restriction itself on the server. IDOR falls under Broken Access Control, which is AO1 in the OWASP Top 10 for 2021, meaning it's ranked as the single most critical web application security risk. It was first formally named back in 2007, so this isn't a new problem. It's just one that is continuously happening, but it is also widely overlooked. And the root cause is almost always the same: a missing or a broken server-side authorization logic. How does IDOR work? In practice, it's very simple. Here's a classic example. Imagine you're logged into a web application, and after logging in, you see a URL that is like this, the one that is shown on the screen. Now, there is an ID that says 1042. This ID is a direct object reference. The application is using your user ID directly in the URL to fetch your profile from the database. Now here's the problem. An attacker who's also logged in simply changes that value from ID 1042 to ID 1043. If the server doesn't verify whether the attacker actually owns the account with the ID 1043, it will just return that user's profile's data. So the flow looks like this. The attacker logs in, modifies the object ID in the request, and then the server processes it without even checking the ownership. And the attacker gains access to another user's data. Just like that, simply. No complex exploitation needed, just by changing from 1042 to 1043. Types of IDOR. IDOR doesn't just happen in URL parameters, it shows up in several different forms. The most common is the URL or query parameter, where an ID is directly visible in the address bar. Here, for example, it says invoice underscore ID equals 5001. Like from the previous slide, by changing just one number, if there isn't an authorization check, the attacker can easily gain access to another person's data. Then there is the body parameter IDOR, where the object reference is passed inside a post request or a JSON payload, such as the one that's shown on the screen. This is slightly harder to spot, but just as easily exploitable. There's also a file path IDOR, where a user can directly access files by modifying the file path. And finally, indirect reference IDOR, where the ID is encoded or hashed in a predictable way, like a base64 encoded token. Many developers think encoding is the same as security. It isn't. Now let's look at some real-world cases that show how serious this vulnerability can be. In 2012, Facebook had an IDOR vulnerability in their photo API. By changing the photo ID in API calls, an attacker could view private albums belonging to any user on the platform, completely bypassing the privacy security. In 2016, Uber had an IDOR in the trip API. By simply changing the trip ID in the request, attackers could access the ride details for any arbitrary user, including the pickup and the drop off locations, which is a serious privacy concern. And in 2019, Instagram had an IDOR vulnerability that exposed private story content to unauthenticated requests. Private content that users specifically restricted was being served without any ownership verification. These aren't small companies with weak security teams, these are major tech platforms, and that tells you how easy it is to overlook this class of vulnerability. Impact and risk. So, why does IDOR matter so much? Let's talk about the real world impact. The most immediate risk is data breach. Unauthorized access to personally identifiable information, medical records, or financial data. IDOR can also lead to full account takeover if an attacker can modify account details or password or reset the password tokens of any other users by exploiting an IDOR. They gain complete control of that account. There is also a significant privacy violation angle, exposure of private files, direct messages, or personal documents. And finally, there's a regulatory risk. If your application exposes user data through IDOR, you could be in violation of GDPR, HIPAA, or any other data protection regulations, which can lead to substantial fines and reputational damages. Now let's walk through the practical demonstration. This was performed in a controlled lab environment, specifically DVWA, the DAM vulnerable web application, which was running locally. Here are the steps we followed. First, we logged in as a regular user on the lab application, and then we used Bobso to intercept the outgoing HTTP request. Next, we identified the object reference in the request, in this case a user ID parameter. We then manipulated that parameter to reference a different user's object. We observed that whether the server returned data, whether it returned the data it shouldn't have. And finally, we documented our findings, which was the endpoint, the parameter, and the difference between the expected response and what the server actually returned. This 6-step process is the standard methodology for testing IDOR, and it works in a bug bounty hunting and penetration testing alike. Tools for testing. Let's quickly cover the tools we used and that you would use in a real IDOR testing scenario. Burbsode is the industry standard for intercepting and manipulating HTTP requests. The repeater module is especially useful for modifying parameters and resending requests. The OWASP Zap is a free open source alternative that also allows you to intercept and scan web requests automatically. Postman and curl are great for manual crafting API requests with modified object IDs, especially for testing REST APIs. And for practice environment, DVWA and BWAP are purpose-built vulnerable applications that let you safely practice IDOR and other vulnerabilities without any legal or ethical risk. Detecting IDOR. How do we actually find IDOR vulnerabilities? Here's what to look for. Scan your application for sequential or predictable IDs appearing in the URLs, API endpoints, or request bodies. Try changing numeric IDs, GUIDs, and file names to see if the server validates ownership. A great technique is to create 2 separate test accounts and try accessing account B's resources while authenticating as account A. Also check API endpoints for missing authorization headers. Some clear signs that you found an IDOR is the server returns differently and the server returns different data depending on which ID you send. It returns an HTTP 200 instead of 403 when you access another user's resource. If it returns sensitive data without verifying ownership, or indirect references that can decode to a real user's ID. How do we fix this? There are 4 key remediation strategies. First and most importantly, implement server-side authorization. Before running any data, the server must verify that the authenticated user actually owns or has permission to access the requested object. This check must never be skipped or delegated to a client. Second, use the indirect reference map. Instead of exposing raw database IDs in URLs or API response, Map them to session scope tokens or non-sequential GUIDs. This way, even if an attacker tries to guess the IDs, they cannot correlate them to real record. Thirdly, apply the principle of least privilege. Users should only have access to minimum set of resources they need. Deny everything by default and explicitly grant access only where it is needed. And fourth, implement input validation and logging. Log all object reference access and set up alerts for unusual cross-user patterns. For example, one session accessing dozens of user ID in a short time frame. Let's wrap up the key takeaways from today's section. IDOR is a broken access control issue, which was ranked in the top 10 for 2021. It occurs when applications expose internal object reference without enforcing authorization checks. It affects URLs, post bodies, and file paths, and including encoded references. The consequences can include data breaches, account takeovers, and regulatory penalties. The fix is always to validate ownership server side and replace predictable IDs with indirect reference map. The final reminder, always test only in authorized lab or sandbox environment. Never run these tests against live system without explicit written permission. Now we'll be looking into the practicals that was conducted. Now let's look at the actual evidence from our lab demonstration. Here it shows our initial setup. We're running a DVWA on a local host with the security level set to low. This disables most defenses, so we can clearly see the vulnerability. You can see the DVWA authorization bypass page, which is where we'll be triggering the IDOR. Now here it shows the interception stage in the burp set. Once we performed an action on the page, the burp captured the outgoing HTTP request. We then sent that request to the repeater module so we could modify and resend it manually. Here in the original request, you can see the ID is set to 2, which corresponds to an account of Gordon Brown, or logged in test user. We then modified from 2 to 1, which is the admin account. We resent the request and still authenticated it as Gordon Brown. This confirms the vulnerability. The server responded with HTTP 200 OK and returned a success result. The admin record ID 1 was modified using Gordon Brown's session with no ownership check performed by the server whatsoever. This is a textbook IDOR exploitation. A low privilege user modifying a high privilege record with nothing more than a parameter change. Here the IDOR is confirmed, which is the vulnerability being confirmed here. Thank you.